For this one, here's our slope right here. It's negative, so that means when we have our least squares regression line, it's going to be pointing slightly down and to the right. So it's going to be a bit of a negative correlation for us. So if you look at slope as number 12, B, slope is your rise over your run. So this is your change in y over your change in x. So our slope is actually 0.00634. And then we'll put that over a 1. So if your x is going up by 1, your y is going to be going down by whatever this number is. So our x is the weight, and our y is the miles per gallon. So if x, the weight, goes up by 1, increase of 1 pound in weight, the mean change in miles per gallon, that looks like it's going to be it. It's not going to be a ratio between their averages. It's not just miles per gallon, and it is appropriate. So it's not the mean weight. So here you want to see if you increase your x by 1, your y is going to increase by the slope. Okay, and then for the y-intercept, for your y-intercept, that's what happens when your x equals 0. So for this problem, if x equals 0, then our y is going to equal 42.7. But we need to talk about whether it's appropriate or not. So if x equals 0, x represents the weight in pounds for a car, and can you have a car that weighs 0 pounds? Right, so this is going to be not appropriate. Here, it doesn't make sense to talk about a car that weighs 0 pounds. Right, so part C, they're asking us to predict the miles per gallon. Whenever they ask us to predict, we're going to use the least squares regression line.
Is the y-intercept always not going to be appropriate to interpret?
Not always. We had, our example last time was when we looked at how deep we are when we start drilling. And so if that's the case, our depth being 0 is okay. That just means we're not below ground, we're right at the surface. Or if you're looking at something like temperature, where your temperature can be 0, and that's fine too. So it just kind of depends. Most of the time it's not completely appropriate, but there are some cases where it would be, and you can't do it. Anytime you're measuring the weight of somebody or somebody's height, it's not going to be appropriate. All right, so for part C, we're going to predict. So whenever we predict, that's using our least squares regression line. And then they tell us that we're doing car D. So for part C, whenever they say predict, we're going to use least squares regression line, which is y hat equals negative 0.00634 plus 42 point something. And then they ask us to find the residual, but we'll do that next. 42.7. And then they say to do it for car D. So we're looking at car D. We know that our x is 3670. So that's the number that we're going to plug in to our formula. Oops, there should be an x after that, sorry. So if we're looking at car D, we're going to take that x value for car D and we're going to plug it into this formula. So y hat equals negative 0.00634 times 3670 plus 42.7. Should get back our value. .43. Okay, and then we have to calculate the residual. And this part won't be on the test where you have to calculate the residual. Because it's the difference between the observed and the predicted, but I don't remember which one comes first. So let's see. down here. Okay, so here we've got the residual is the observed minus the predicted. So, write that down. So, residual is observed minus the predicted. And again, this predicted value, that's going to be what we got from our least squares regression line. And then the observed value is going to be what we actually saw in our original data set. So we've got 19.43. So the predicted, that's going to be from our least squares regression line, and the observed value, that's going to be just from our data set, what we actually saw that the car had. So car D actually had 17 miles per gallon, so we'll do 17 minus 19.43, and we should get a negative 2.43 for the residual. And that's okay, residuals can be negative and it's not a big deal, it just means that it's, our observed value is below the least squares regression line. So residuals can be negative. And then when they ask you if it's above or below average, remember average is just going to be what we predict the least squares regression line to be. So if our average is 19.43 and our observed value is 17, that's less than our average or predicted value, so this one's going to be below average. Here they want us to label the residual. So residual is always going to be our vertical distance. So you don't want to have D or B, because if you look at D and B, this is horizontal, and you don't want that red to be in horizontal, because the residual is vertical. So it's not going to be those two. If you look at C, this is a vertical distance, and that looks pretty good from the point to the line. But let's double check A. A is going to be different because this one, if our x value is 3670, that's this point right here. So this point doesn't really line up with our x value, so I don't even know what number they're using right there. But it's not, because it needs to be this point right here in the vertical distance. So that's not going to be right. We'll select C for that one. Which I know it's there. That one's kind of a long one. Are there any other questions? Yeah.
Number 11.
Yeah. Okay, so in this case, we don't have data values, they just give us the least squares regression line. So, looking at the difference, age difference in husbands and wives and the percent split. Here we go, so our slope is going to be the number in front of our x, that negative number right there. So we're going to have a negative correlation between these two variables. So again, we're going to be using this formula. Slope is the same thing as rise over run, which is your change in y over your change in x. So our slope is negative 0.0527. And so on the bottom we have our change in x, which is 1. So every unit increase in x. So our x value is the literacy rate. And then the y value is the age difference. So here when we write out our slope like this, our literacy rate, which is x, that's changing by 1, that's a unit increase. Whenever it's changing by 1, they just say that's a unit increase. So we're going to do a unit increase in the literacy rate, and then our y value, which is the age difference, is going to fall. The reason it's falling is because this is negative. And it's going to fall by 0.0527 because that's what my